This is CPM Calculus, Chapter 3, number 168. Evaluate each limit. If the limit does not exist, say so, but also state if y is approaching positive or negative infinity. Alright, A, we have the limit as x approaches 0 of the square root of 3 minus x minus square root of 3 over x. So whenever you get a limit, you can just try to plug in x equal to 0 and see what that gives you, right? So you get 3 minus 0 minus square root of 3 over 0. And that we know because we have a 3 in the denominator, right? A 0 in the denominator, also square root of 3 minus square root of 3 over 0. That's 0 over 0. This is indeterminate, right? We know that we need to investigate a limit further if there's anything undefined or indeterminate about what it equals, all right? So let's go ahead and we know that this means investigate further. So let's write that, investigate. Okay, so when you're investigating these, what you can look for are like basically, do we want x in the denominator? No. And we might not want this in the numerator. So when you're given a square root, right, it might be complicated to think about combining these, but we can get rid of the square roots in the numerator if we multiply by the conjugate, okay? So this is equal to the limit as x approaches 0 of square root of 3 minus x minus square root of 3 over x, right? And if I want to multiply this whole thing by 1, and I'll represent 1 as the conjugate of this, so it's going to be square root of 3 minus x plus square root of 3. I'm going to put that in the denominator as well, plus square root of 3, right? That's the conjugate. I'll even write that here, conjugate, right? Then we know that when we multiply the numerator, so let's go ahead and multiply this. The numerator, we're going to multiply the first terms. I'm going to use FOIL. Like the first terms, we multiply them, well, they're the same and in the square root, so we get rid of the square root. Okay, that's the first term. Plus the outside term, I'm going to go ahead and write it out, is going to be square root of 3 here and square root of 3 minus x there being multiplied. The inside term is going to be negative square root of 3 and square root of 3 minus x. And the last term is going to be negative, right, because we're minus and a positive. And they're both the same in the square root, so we could just take it out of the square root. Okay? That's going to be all over x times square root of 3 minus x plus square root of 3. Okay? So there's kind of a nice thing that's going to happen because this is going to get rid of the square root. Because you'll see that, let me use a different color, these terms right here cancel out, right? Because you have a positive and a negative. So what that equals is limit as x approaches 0 of 3 minus x, right from here, minus 3 over x times square root of 3 minus x plus square root of 3. And the neat thing is now the 3 and the negative 3 here are going to cancel. So that's equal to the limit as x approaches 0 of negative x over x times square root of 3 minus x plus square root of 3, right? And now we can go ahead and cancel out these x's, right? So these will cancel out, and that is really the cool thing to do it this way. Okay, so that's equal to the limit as x approaches 0 of negative 1 over square root of 3 minus x plus square root of 3. All right, now we can go ahead and plug in 0. Okay, so that's going to give us negative 1 over, no longer having the limit, square root of 3 minus 0 plus square root of 3. And that equals negative 1 over square root of 3 plus square root of 3. And that simplifies to negative 1 over 2 square root of 3, right? The only thing we want to maybe get rid of is the square root of 3 in the denominator. So we multiply by square root of 3 over square root of 3. And that will get rid of the root in the denominator, and that will be negative square root of 3 in the numerator over 2 times 3 is 6 in the denominator. All right, so that is the limit as x approaches 0 of our function. All right, that's 3 right here. Let me just make sure it's readable. All right, now I want to show you just a cool feature in our TI-89 calculator, right? So let's go ahead and let me scroll up here so we can see the original the limit question. Okay, so our calculator, if you see F1, F3 here has calculate, right? And number 3 asks for a limit, okay? And the inputs here are the expression, comma, the variable, comma, what that variable is approaching. So we want to put the expression square root of 3 minus x minus square root of 3 divided by x, right? That's going to be the expression, comma, x is the variable, comma, 0 is what it's approaching, okay? And if I put in all the, oops, I missed a parentheses in here. So if I put in all the parentheses, right, you can see that it's going to appear here, the limit as x approaches 0. This is exactly what I want it to look like, right? They match. Okay? And what do I get? I get negative square root of 3 over 6. And what was my answer? Negative square root of 3 over 6. So there's just a quick little hint on multiple choice questions. You can go ahead and check with your calculator or use your calculator. But if you're asked to show your work, make sure you can show all of your work to get the answer. But you can always check your answer using your calculator. All right, let's go ahead and move on to part B. Okay, because we're asked to evaluate a few different limits. Part B is the limit as x approaches 2 of x plus 3 divided by x minus 4. And like I said earlier, let's always try to plug it in, just to see. And if we plug it in, we get 2 plus 3 over 2 minus 4. Well, look at that. We get 5 over negative 2. And we can write that as negative 5/2, right? Either way. And that was a pretty simple one to find. And that is the limit. Again, we can use our calculator if we wanted. Let me just show you. Go ahead and go to limit, right? And our expression is x plus 3 divided by x minus 4. So this is a neat way you can check your answers. Comma, the variable is x, and it's approaching 2. All right, and negative 5/2. All right, so now that you know how to use your calculator to do this, that's kind of a neat little helpful tool. All right, let's go into part C. Part C is asking us the limit as x approaches 2 now from the right, all right, of this expression. So let's go ahead and look at this. So first of all, can we break this function into what it's going to look like when we're approaching from the right? Well, let's first look at x minus 2, absolute value of that, right? We know that that is equal, I could even sketch it, right? It's basically the absolute value function shifted to the right by 2 units, right? And above, so this is 2. To the right of 2, we know that it is just x minus 2, right? And that is when x is greater than or equal to 2. And to the left of 2, on this side, we know that, well, whenever we have a negative value of x, it's going to be positive. So it's going to be negative x minus 2 for when x is less than or equal to 2. Okay? And we could even plug in a value like 1, right? 1 minus 2 is negative 1. And that becomes a positive 1 because of the negative sign. All right? Okay, so given that, we know that here we're looking at the right side of 2. So when we're looking at the right side of 2, the absolute value is going to look like this, right? So I can go ahead and simplify this and say this is equal to the limit as x approaches 2 from the right of x squared times x minus 2, right, over x minus 2. And I can go ahead and go from here to there, knowing that since we're on the right side of 2, the expression is equal to this, okay? So then I can go ahead and see, well, if this is true, these cancel out, right? And that's equal to the limit as x approaches 2 from the right of x squared. And we know that that is just the same like as it approaches 2 or from 2 from the left, which is we could plug it in, and that's 2 squared equals to 4, okay? So that's part C, and let's go on and do part D. All right, part D asks us the limit as x approaches infinity of e to the negative x plus 1. All right, so what we need to be careful about, because we know if we plug in infinity up there, what's going to happen? So let's go ahead and rewrite this so we can see it a little bit easier, because a negative exponent means 1 over e to the positive exponent, right? We take the reciprocal and the exponent is positive, plus 1, right? And if we plug in an x going to infinity, right, e to the x is getting bigger and bigger and bigger whenever x gets bigger. So 1 divided by a big number approaches 0. So I'm going to plug in infinity in here, kind of not really plugging it in, but as x approaches infinity, we know that this approaches, let me put, this arrow approaches 1 over infinity, right, which approaches 0. So the limit as x approaches infinity is equal to 0 plus 1, right, because we still have a plus 1, and that's equal to 1. All right? So that ends CPM Calculus Chapter 3, number 168.